Questions 26 through 29. Listen to a teacher talking in a history class.
People become pirates for various reasons. Sometimes honest sailors left their ships because life on them was so miserable, and they couldn't bear it. These seamen often turned to piracy in order to survive. Others were in search of riches like gold, silver, and jewelry. Some simply wanted to have adventures. Stories and movies have created an exciting image of pirates as dangerous men with beards. In reality, however, pirates led a miserable life. They were often drunk and argued a lot. Many pirates died of injuries and illnesses. Some were shot or left at sea. Others were captured and sentenced to death. Most pirate ships had a captain who was in command during a battle. The most powerful person on board was the quartermaster, who divided the stolen goods, or loot, among the crew. He also had the duty of punishing pirates who did something wrong. Both the captain and the quartermaster were elected by the crew, and they could be removed if they did not do their job well. Most pirate crews had rules that every member had to obey. Pirates who stole other men's things were often set ashore on a deserted island where they would die of thirst. Sometimes they were given a pistol and a bullet to kill themselves. Because pirates were mostly interested in stolen goods, they killed very few people, and often let their enemies free after they had attacked and robbed them. They also attacked towns along coasts. Sometimes they took prisoners and demanded money for their freedom. The pirate flag became a well-known and feared symbol of the seas. It often showed a white skull and crossbones on a black background.
Now, answer the questions. 26. Which is not the reason that sailors became pirates? 27. How was the pirate's life? 28. What was the captain responsible for? 29. Which is true about the pirates? Questions 30 through 33. Now you will hear part of a radio program.
Dragonflies are among the most ancient of insects. They were darting across rivers and lakes long before dinosaurs appeared, and have evolved many mechanisms to survive. Powerful eyes and impressive flying abilities are chief among their abilities. They can fly further, higher, and faster than most insects, sometimes at speeds of up to 70 kilometers per hour. Dragonflies are able to propel themselves upwards and downwards, backwards and forwards, side to side, and hover in midair. And many of these flying abilities are thanks to the insect's distinctive wings. The dragonfly has two sets of wings, one behind the other, that can be used in tandem or independently. Running through each wing is a network of veins that adds strength and flexibility. This allows the dragonfly to curve and cut through the air.
Why do dragonfly wings look glassy? What are they made of?
This vein structure is held together by a very thin shiny film made of chitin, the starch variation that makes up the exoskeletons of most insects. A great number of invertebrates, including prawns, spiders, and insects, have exo or external skeletons, meaning that unlike humans, they are soft on the inside, hard on the outside. Chitin is not elastic, so that when the animal wants to grow, it has to push out of its wings, split open the structure, and wait for a new exoskeleton to harden. The most well-known example of this is the cicada pushing out of its shell. The wings are really smooth, with no bumps, which makes the chitin appear glassy and reflective. Chitin in its natural form is translucent, and it's the extreme thinness of dragonfly wings that makes them appear glassy.
This shininess is not exclusive to dragonflies.
There are a lot of other insects with the glassy wing. Flies, bees, wasps. Many of them have the same transparent, glassy, chitinous structure. If you were to remove the colorful scales from a butterfly, their wings would be glassy too.
Oh, I see. Thank you for talking so much.
Now answer the questions. 30. Which is not the feature of dragonflies' wings? 31. What are chief among Dragonfly's abilities? (32) Why do dragonfly wings look glassy? (33) Which insect doesn't have glassy wings? Questions 34 through 38. Now you will hear a speaker talking to a class on a tour by the Oasis of the Seas.
Hello, everyone. Thank you for touring Bith Oasis of the Seas. I hope you can have a good time on the ship. The Oasis of the Seas is the world's largest cruise ship. It can carry up to 6,200 passengers, who are served by our 2,000 crew members. The vessel is 40% bigger than any other cruise ship in the world. It has a weight of 225,000 tons and is 5 times the size of the Titanic. It has a total of 15 decks and is as high as a 20-story building. The ship was built in Finland and is owned by Royal Caribbean International. Its maiden voyage is scheduled for early December 2009. The ship is stationed in Fort Lauderdale, Florida, from where it will go on week-long cruises of the Caribbean Sea. The Oasis of the Seas has virtually everything a tourist can dream of. The biggest attraction is a giant open-air theater for 750 passengers that is a swimming pool by day and an entertainment arena at night. Passengers can wander through a park full of real trees and exotic plants, eat and drink in 24 restaurants, or travel up and down between decks in a movable bar. There is something for everyone. A small golf course, a basketball court, an ice rink, and 2 rock climbing walls for those looking for athletic activities. Mothers can leave small children in nurseries while they go shopping in the ship's boutiques. The owners hope that the Oasis of the Seas will earn them a lot of money. The vessel cost over $1.5 billion to build, and with a starting price of about 1,700 euros for a 9-day cruise, it is not exactly cheap, but spending a holiday on the world's biggest ship should be worth something.
Now, answer the questions. 34. How many people can the ship take? 35. Who owns this ship? 36. Where will the ship go on its first voyage? 37. What is the biggest attraction on this ship? 38. What's the purpose of the speaker? Questions 39 through 42. Listen to part of the discussion in a science class.
Today, in the science lesson, let's discuss Hooke's Law. First, you need to put some weights on a spring and measure the length of the spring. Then, keep measuring the length of the spring for different weights and draw a graph showing weight against length. Okay? What was that, Tom? Nothing. I just knocked my bag off the bench. Well, it shouldn't have been on the bench. That's why we have rules. Okay, get your books out and we'll look at yesterday's experiment. You should have found that the points on your graph made a straight line. This proves that the more weight there is on a spring, the longer it gets. That's Hooke's Law. What's more, if you double the weight, you double the length of the spring. But we didn't get a straight line, Mr. Carey. You have to wait until I call on you before you speak, Tom. That's the law of this classroom.
Tom, you'll have to tell Mr. Carey sometime. He'll find out that you broke his spring sooner or later. You've broken the law twice, and you broke Hooke's Law because you broke the spring.
Quiet now. I saw no hands up. But what's that you're saying, Mary? Who broke the spring? Did you break it, Tom? Yes. I just wanted to try a 5-kilogram weight. But Mary's right. If the spring broke, then you did break Hooke's Law. Another one without his hand up. I guess we're not going to get on until I let you talk this out. Okay, but let's at least try to talk one at a time. Now, come on, Mary. Explain yourself.
Well, you said that Hooke's Law is that a spring gets longer when you apply more weight. And that's what I got. I figured out this relationship. First, you have to take 20 millimeters off the length measurements, because that's how long the spring is to start with.
And then what?
Then you multiply the number of grams by 0.3 to get the extra millimeters you have to add on.
Can you explain that to the others?
Sure. The spring was 20 millimeters long to begin with. And if you put X grams on it, it gets longer by 0.3 times X millimeters.
That's explaining. Can you give us an example?
Well, we put 500 grams on and it measured 170 millimeters. That's the original 20 plus 150, because 150 is 0.3 times 500.
Oh, when Tom put the 5 kilogram mass on, how about the result?
That's 5,000 grams. Then the spring should have been 1,520 millimeters long.
Right, Mary. Thank you.
Now answer the questions. 39. What did this class mainly talk about? 40. What's Hooke's law? 41. Why did not Tom get a straight line on his graph? 42. What's the first step when you get the result of an experiment?